Welcome to a professor's video for chapter 10. I'm just going to explain kind of a few of the ideas and then talk about how to do these on the calculator. Well, at least some of it on the calculator. So the first section is 10.1. It's called chi-square goodness of fit. This test is used in a situation where you expect some values to be distributed into certain categories following some sort of distribution that you know. The test will be to see if the actual data follows the expected distribution well enough to say that it follows the expected distribution or not. In the question, you will be told this expected distribution. The only question that I get fairly often for this really is about the expected distribution. Usually they list the categories and tell you what percentage of the data is expected to fall into each category. Sometimes, though, they throw you a bit of a curveball and say something like, car accidents are expected to be uniformly distributed across days of the week. Alright, so uniformly will be the key word. The word uniformly means that the expectation is that you will see the same number of accidents on Monday as you do on Tuesday, as you do on Wednesday, Thursday, etc. The same number each day of the week. When you get a question like this, what you do is just divide the total number of whatever is being counted by the number of categories and put that number in each category. For example, in my example about days of the week, if you had 200 accidents, then 200 divided by 7, 28.5714. You divide by 7 because there's 7 days of the week. You then put 28.57 accidents in for each day of the week. If the question had 5 categories instead of my example was 7, then you'd do 200 divided by 5 equals 40, and you'd put 40 into each category. Alright, 10.2 is called the chi-square test for independence. In these questions, there are two different factors or variables. Let's say a drug is being tested against a generic version of the same drug. One variable would be what treatment was given to the test subject during the experiment, and it would be something like name brand or generic or placebo. Okay, that'd be 3 separate categories: name brand, generic, placebo. Not 3 separate categories, 3 separate possibilities. The other variable would be, did the subject's condition improve or not? So here's what this question looks like out of my math lab. I cut and pasted this out of here. It says use the contingency table to the right to calculate the marginal frequencies and find the expected frequency for each cell in the contingency table. All right. So the marginal frequencies are the totals here, out in the right-hand column and at the bottom here. And then the expected frequencies are these numbers down here in this table, the third table. Okay. This is one of the early homework questions that is just asking you to find all of the expected frequencies. All right. Later questions will ask you to perform a hypothesis test about whether or not these two variables are independent. Finding the expected frequencies is part of finding the test statistic. Your TI-83 or TI-84 calculator has a built-in function for this. All right. Here's how to do this one. I recommend that you grab your calculator now and work through this with me. If you have to pause the video a few times, that's fine. So step 1, count the number of rows and columns in the chart, also called a matrix. So here's our chart from the beginning. We have 1, 2 rows, and 3 columns. The labels don't count. 2 rows and 3 columns. 2, on your calculator, the button in the first column labeled with an x with an exponent of -1, so x to the -1, has a second function of matrix. So what you want to do is select second matrix. 3, use the right arrow key to select edit at the top and then enter. Notice that the first number in the top row is highlighted and flashing. This is the number of rows. The number next to it is the number of columns. For this question, type 2 and then hit enter, and then 3 and then enter, right? Because it was 2 rows and 3 columns. If it had been 5 rows and 3 columns, you would have been 5, enter, 3, enter. All right, it's just number of rows, enter, number of columns, enter. All right. Notice now that the matrix on the screen now has 2 rows and 3 columns, because that's what you enter, 2 rows and 3 columns. Enter the numbers from the first matrix at the top of the question above into the calculator. Start by entering the 19 in row 1, column 1, and then enter. Okay, so here's the 19 right here. All right, so we're going to enter that, and then hit enter, and you'll notice that what's going to happen here is the cursor is going to move over to the 27. So you type 27 and hit enter, it'll move to the 18. You type 18 and hit enter, it'll kick down to the 13, etc. So then once you get all 6 of them entered, select stat. So you hit the stat key and then enter, or just select stat actually. I'm sorry, just stat key. Then use the right arrow to select test. Then use the up arrow, okay, to select chi-square test. You'll see there's one of the entries will look just like that. Alright, next use the down arrow to select calculate and then enter. Okay. The chi-square, looks like a capital X squared on the next screen, is the test statistic, and the p-value is also there. You'll use these numbers when you do the hypothesis test questions. For this question, select second matrix again. Arrow down once to select the B matrix and then hit enter twice. Okay. The B matrix is now, that was twice right on the hit enter, alright? You're going to hit it twice. Okay, the B matrix is now shown on the screen with the first column shown on the screen and the other columns off the screen to the right. The values in the B matrix are the expected frequencies. You can round them to 2 decimal places, and they are the values that go into the contingency table, which is the last matrix in the display above. You can see the other values that you need by using the right arrow. 10.4, last section. ANOVA, which is short for analysis of variance. This one has the easiest calculator calculations. In these questions, you'll have 3 or more variables and a list of values for each variable. The test statistic for these questions is called an f-test. To calculate the test statistic and the p-value, put the values into L1, L2, and L3, etc. You know, if there's 3 variables, then the values go to L1 through L3, 4 variables, L1 through L4, etc. So let's try the following example. I cut this table of values out of my math lab, all right? So, what we're going to do here, one, is use stat edit screen to enter the values above into L1, L2, and L3. So the first column here goes into L1, all right? The next column, so that's this here. Oh, it's not going to let me highlight that. All right. So the first column goes into L1, the second column goes into L2, and the third column goes into L3. Once you have the values entered into the calculator, then you're going to select Stat and then Test again. Arrow up once to select ANOVA and then Enter. This one has 3 variables, so we'll enter L1, L1, comma, L2, comma, L3. It's important, you do have to enter the commas, right? And if you have forgotten, L1 is second and then the number 1. L2 is second and the number 2, etc. The comma key is just above the 7 key. Alright, yeah, so don't forget the commas. Once you have them all listed, hit enter. On the next screen, you get a bunch of stuff. The number labeled with the F is the test statistic. You can get the other numbers you need from this screen too. Use the down arrow to see the rest of the numbers. The first arrow labeled with a DF is the degrees of freedom for the numerator. And the DF for the denominator is just below the bottom edge of the screen. Use the down arrow to see it. This is the end of the last video for our course. If you have any other questions, please don't hesitate to ask me. I am always glad to help.